So guys, as we have discussed in our earlier video, we are going to come with a new concept in a surface chemistry called as colloids. So first and the foremost thing, let us make sure that whether we are seeing these colloids in our day-to-day life. Of course, Alva. So whenever you are going in nearly at 5 o'clock AM for a morning walk, what you can experience a beautiful, or we can feel the cool breeze, Alva. But certain times in that cool breeze too, you are also experiencing some liquid droplets. Have you ever observed it? Of course, we say it as a fog or a mist. Yes, if I am not wrong. I'm using the word as a fog, not as a smog. I'm talking about fog. That means what? In that air, there are some liquid droplets. Of course, those liquid droplets have been felt by us, but we are not able to see it. The same phenomenon, or we can say it is one of the greatest example for the topic of your colloids. Let us understand. Then what do you mean by this colloids? So basically, whenever we talk about a solution, whenever we are talking about a solution, you have to remember that the solution will be categorized into three important types. First is called as what? As a true solution. Yes. Let me go with the last part. That is called as what? Suspension. So in between this true solution and the suspension, there lies another heterogeneous system. Mark my words, another heterogeneous system, which itself is called as colloids. So let us first understand what do you mean by this true solution and that of your suspension. As I have said, take a beaker, put some water to it. You have filled some water. So this is my first beaker, which is representing my true solution. Yeah. Whereas this is my third beaker, which is a representation for my suspension. So in this water, if I am going to add some salt particles, what I am doing? I am adding some salt particles. You stir it. Now my question is, after stirring the salt, or after the addition of the salt and after stirring it, first important question, can you observe the salt particles? Can you observe the salt particles? Of course, the answer is no. Alva. So what is my question I am asking? You took a beaker which has been filled with certain amount of water. You have put salt to it and you have stirred it. The question is, after some interval of time, can you observe the salt particles? Of course, the answer is no. Let me go with my suspension part. I have took some water and to that water I am adding certain sand particles. Okay? And you just stir it. The question is same. Whether can you observe the sand particles? Yes. The answer is yes, we can observe the sand particles. Alva. So I will say that the solution of salt in water, yes, is an example of your true solution. Whereas the suspension of sand in water is called as what? Is an example for your suspension. Then what is the main question lying over here? Remember, whatever we are going to distinguish the true solution from the suspension is about what? Particle size. Alva. Whatever the true solution we are observing, here we are seeing that the particle size is what is happening. It is less than 1 nanometer. Alva, that is 1 into 10 to the power of minus 9 meter. What is happening in a true solution? The particle size is less than 1 nanometer. That is the reason we are not able to see from our naked eye. But when we are coming with respect to the suspension, what is happening? The particle size is greater than how much? Nearly 1000 nanometer. Nearly 1000 nanometer. That is the reason we are able to see these particles, that is your sand particles. Why I am saying that? Because whatever the system which is existing in between the particle size of 1 nanometer to 1000 nanometer, I am repeating, the system in which the particle size lies in between 1 nanometer to that of your 1000 nanometer is itself represents a system of your colloids. So this is the main important 3 extensions one has to know when you're going to understand the part of your solution. One is your true solution. What is happening in a true solution? So these are the solution in which the particle size is less than 1 nanometer, 1 into 10 to the power of minus 9 meter. Whereas the suspension means what? So it is a system in which the particle size is greater than 1000 nanometer. A system which exists in between these true solution is suspension, in which the particle size in between 1 nanometer to 1000 nanometer itself is representing your colloids. So what you can say, whatever the fog you are experiencing, it is also having the liquid droplets suspended in air. Alva, what is happening? Remember, the liquid droplets are suspended in air. They are having the dimensions of what? 1 nanometer to 1000 nanometer. Then how can we define this colloids will be our next question. Remember, whenever we are talking about a fog, of course we know that it is not a true solution. Neither it is a suspension. It is existing in both. That means what? Whatever the particles are there, neither it is getting completely dissolved, neither it is getting completely undissolved. So it is existing in an intermediate state. That is, it will be not dissolved and it will be also somewhat dissolved in between this state. So how can it define this colloids now? Remember, it is a heterogeneous mixture. Or we can say it is a heterogeneous system anta helbodu alva. You can only experience it. Gaali untu alva, whatever you are going for a walk, whenever you are going for, of course you can feel the cool breeze, and along with that you can also feel the water droplets. That means what? In that air, the water droplets has not been dissolved. In turn, what has happened? They have been suspended, or they are present in it. Alva. So what we can say, they are not mixing with the medium. If I take air as my medium, this liquid droplets as a phase. So what is happening in that air medium? Our liquid droplets is not mixing. So we can say as what? It is not a homogeneous. Instead of saying not a homogeneous system, we will be using the word as what? Heterogeneous. Alva. So what you can say, colloid is an heterogeneous system in which one substance, alva, in which one substance is dispersed, in which one substance is dispersed as what? Very fine particles. Very fine particles. That means what? Very small dimensions, molecules. Whatever the dimensions are there of those molecules, that will be very small. That is represented as called as what? Very fine particles. So this dispersed very fine particles, in other terms, we call it as a dispersed phase. What we can call it as a dispersed phase, in which one substance is dispersed as a very fine particles in another substance. And this another substance is given by a word called as what? Dispersion medium. Let me take the same example of your fog. Of course, if I consider this is your air marked, Okay, this is your air. And in this air, what has happened? There is a small liquid droplets. So what is happening? Let us go with it. Colloids is what? It is a heterogeneous system. How can we say that? Of course, in this air, the liquid droplets has not been completely dissolved. Instead of that, what has happened? It has been suspended. Alva, akili nim kal hingirutto. Alva, adu kuda one example of your heterogeneous system. Similarly, in air, your liquid droplets are present. You can just relate those two examples. So it is the reason. First part is why it is called as an heterogeneous system. The second part is what? In which one substance is dispersed. That is called as what? As a very fine particle, which is called as what? Dispersed phase. So ಇಲ್ಲಿ ಯಾವುದು dispersed ಆಗಿರೋದು? Of course your liquid droplets. Alva, in the size of what? Very fine particles. That is of very smaller dimensions. So these liquid droplets in a fog will be represented as what? Dispersed phase. In another substance, alva, one phase has been dispersed in another substance. Liquid droplets has been suspended in your air medium. Alva. So this another substance in this case, that is in case of your fog, is called as what? Your dispersion medium. Alva. Fog anta example tagondre, of course, is an example of your colloids. Because whatever its particle size are there, it exists between that of your 1 nanometer to 1000 nanometer. The next important thing is, what do you call as a dispersed phase and a dispersed medium? What is a dispersed phase? So these are the substances, which has been of a very fine particles dispersed in a dispersion medium. Alva. So that are examples for your dispersed phase. Then what you can call as a dispersion medium? It is a continuous medium. Alva, air ella kade irutte. It is a continuous medium. In that continuous medium, whatever they find in which the dispersed phase are existing, the continuous medium in which the dispersed phase is existing, that is will be called as what? Dispersion medium. Is that clear? So overall, what we can say as a colloid exam, your definition, it is a heterogeneous system in which one substance is dispersed as very fine particles, which is called as what? Dispersed phase, in another substance. And that another substance in colloid language, we call it as what? Dispersion medium. Is that clear? Then we are going to see how to classify this colloids. Classification of colloids. So first important classification, we are going to see the classification based on the physical state. Classification based on your physical state of dispersed phase and dispersed medium. Alva, or a dispersion medium. Let us go on with it. So ನಮಗೆ ಏನು ಗೊತ್ತು, ಫಿಸಿಕಲ್ ಸ್ಟೇಟ್ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಇಟ್ ಮೇ ಬಿ ಅ ಸಾಲಿಡ್, ಲಿಕ್ವಿಡ್ ಆರ್ ಅ ಗ್ಯಾಸ್. ಆ ಒಂದು ಸ್ಟೇಟ್ ನ ಹೇಳ್ತೀವಿ. ಸೊ ಯಾವ್ದನ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೇಕೀಗ ಈ ಒಂದು ಕ್ಲಾಸಿಫೈ ಮಾಡ್ಬೇಕಂದ್ರೆ, ವಿ ಆರ್ ಕ್ಲಾಸಿಫೈಯಿಂಗ್ ಅವರ್ ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಅಂಡ್ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಮ್ದು ಫಿಸಿಕಲ್ ಸ್ಟೇಟ್ ನ ಇಟ್ಕೊಂಡು ಒಂದು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಮಾಡ್ತೀವಿ. ಲೆಟ್ ಅಸ್ ಗೋ ವಿತ್ ದಟ್ ಫಸ್ಟ್. ಓಕೆ, so in that part we are going to see, let us make a column. That is, first let be the dispersed phase. The second one, let it be dispersion medium. Dispersion medium. Then this has been given with a particular name for a colloid. Let us take it as a type of colloid. It is called as type of colloid. And the next part is that of your examples. What in our day-to-day life, whether we are seeing it, we will be coming to know when you are seeing those examples. So let me give you a hint how to remember it. First, let us write the continuous medium. Alva, this is our main medium. For example, if innu nimage artha agilla andre, let us take an example of a salt in water anta consider madre. Enagutte alli salt will be your dispersed phase, whereas water will be your dispersion medium. Alva, ಅದೇ ರೀತಿ ಯಾವುದು ತುಂಬಾನೇ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿರುತ್ತೆ, ಬಲ್ಕ್ ಕ್ವಾಂಟಿಟಿಲಿ ಇರುತ್ತೆ, that will be your dispersion medium. ಅದಲ್ಲಿ ಯಾವುದು ಸಸ್ಪೆಂಡ್ ಆಗಿರುತ್ತೆ, that will be your dispersed phase. So first let us write with dispersion medium. So let us take solid, solid and a solid. Let us make a constant dispersion medium alva. Continuous medium na constant agi itkondu, this is your solid. So first dispersed phase ಗೆ ಹೋಗೋಣ. Let me take it as a solid itself. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು, ಕಂಟಿನ್ಯೂಸ್ ಮೀಡಿಯಂ ಕೂಡ ಸಾಲಿಡ್, ಅದರಲ್ಲಿ ಸಸ್ಪೆಂಡೆಡ್ ಆಗಿರೋ ಪಾರ್ಟಿಕಲ್ಸ್ ಕೂಡ ಏನಾಗಿರುತ್ತೆ, ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. First let us understand when such a system is existing, what is the name of such colloids alva. So it is called as what, remember, solid sol anta ಹೇಳ್ತೀವಿ. What it is called as solid sol. Okay, how can we see whether we are seeing the solid sol in our day-to-day life? Of course yes. So in your home, whenever you are seeing your colored glass ಇರಬಹುದು ಅಥವಾ certain gemstones ಇರಬಹುದು, so they are representing an example for your solid sol. Colored glass ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, dispersion medium ಕೂಡ solid ಆಗಿರುತ್ತೆ. Okay, whatever the colorful materials are there, of course we know what glass is also a form of a solid, and whatever the colored particles are present, that will be also in this solid state. So solid will be your dispersion phase, and that is suspended in your dispersion medium, which is also a solid. So whenever you are seeing the colored glass or a gemstones, it should click to your mind, oh yeah, it is an example for your solid sol. So that is the way of remembering. So let us go with now next state of your dispersed phase. Let me take it as a liquid alva. So ಏನಾಗಿದೆ, dispersion medium is solid, the continuous medium is a solid, and in that solid the suspended particles is your liquid. Common example for boys, we are using it gel alva, gel, whatever gel we can use. So illi kuda this is a name of your colloid. Let me give you certain example. It would be your cheese, or it would be your butter, or it could be also your jellies ನೋಡ್ತೀವಲ್ಲ, the toffees, whatever the toffee we are taking, jellies, they are the examples for your gel. ಹೇಗೆ ಸರ್, ಚೀಸ್ ನೋಡಿರಬಹುದು, ಏನಾಗಿರುತ್ತೆ ಚೀಸ್ ಅಲ್ಲಿ, of course it is having certain solid surface ಅಲ್ವಾ. In that we can experience some slippery part ಅಲ್ವಾ, the slippery, that is the what suspended liquid phase. So that is the reason when the dispersion medium is a solid and the dispersed phase is a liquid, the type of a colloid is called as a gel. Examples in our day-to-day life, we are seeing it, whatever the cheese, butter, jellies we are seeing, it represents the type of the colloid called as gel. Okay, of course the next state is your gas. Remember, it is also called as what, as a solid itself ಅಲ್ವಾ. ಈಸಿ ಆಯ್ತಲ್ವಾ, ನಮಗೆ ಎರಡಿಗೂ ಕೂಡ ಏನ್ ಬರ್ತಾ ಉಂಟು, solid sol. But where is the examples? Of course here we can see as a pumice stone ಇರಬಹುದು, ಅಥವಾ ನಿಮ್ಮ foam rubber ಇರಬಹುದು. Of course foam rubber ಯಾರು ನೋಡಿಲ್ಲ ಅನ್ಸುತ್ತೆ. We have seen this pumice stone, of course girls would have seen it whenever they are going for a pedicure ಅಲ್ವಾ. So they will be using for rubbing your feet with a stone called as a pumice stone. Why it is called? Of course it is a stone, it is a form of your feldspar. Feldspar means what? It's a type of your zeolite itself. So pumice stone ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, it is having a solid part, solid basement. ಆ solid ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, you can see certain pores, and in that pores your gas molecules will be suspended. So that is the reason dispersion medium, which is a continuous medium, is a solid alva, whereas the dispersed phase will be your gas. The type of the colloid is called as what? Solid sol. Example is that of your pumice stone, foam rubber. Okay, so we have seen a one category. When the dispersion medium is your solid, we saw the dispersed phase is your solid, it is called as what? Solid sol. Examples are colored glass, gemstones. So when the dispersed phase is a liquid and the dispersion medium is a solid, it is called as what? Gel. Example is that of your cheese, butter, jellies, all those things. Now when the dispersed phase is your gas and the dispersion medium is your solid, the type of a colloid is called as what? Solid sol. Example is that of your pumice stone, foam rubber, etc. Now let us go with another medium. Let me take it as a constant. Let me take it as a liquid, liquid, and a liquid. Why I am writing it so? Because in order to make you understand, also it should be a sequence of remembering. So let us first go with my solid itself. So now dispersion medium is your liquid, whereas dispersed phase is that of your solid. So what is the type of the colloid? What is the name of it? Remember, it is called as just as sol. What it is called as? Just as a sol. When we are seeing in our day-to-day life, it may be your paints. Paint ನೋಡಿದಾಗ ಏನಾಗಿರುತ್ತೆ ಅಲ್ಲಿ liquid medium ಅಲ್ಲಿ ನಿಮ್ಮ solid particles will be suspended. Of course ಅಲ್ವಾ, ತುಂಬಾನೇ viscous ಆಗಿರುತ್ತೆ. That is the reason. What is happening? A liquid state ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, liquid medium ಅಲ್ಲಿ solids, fine particles of your solid will be existing. The type of a colloid is called as what? Sol. Where we are seeing it examples of paints, even in your bioterm we can see it as a cell fluid cell kuda. This is an example. Cell fluids ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, of course liquid medium ಅಲ್ಲಿ solid suspend ಆಗಿರುತ್ತೆ. So these are an examples for your sol. Remember, sol. Very much important. This is a very much important category. Liquid in liquid. What it is? Liquid in liquid. That is, in liquid medium, a liquid part will be existing. So that is called as what? Very much important. Emulsions. What it is called as? Emulsions. Remember, it could be the best example is your milk. Of course, no need to make you understand why example. Alva milk ali liquid will be suspended. So liquid will be suspended in a liquid medium. The greatest example is your milk. Don't get confused with butter and milk. Butter is an example for your what? Gel. Whereas milk is an example for your emulsions. Of course, your hair cream. Hair cream is also an example for your emulsions. Coming to another class which is called as what? Gas. So which is what? Gas which has been suspended in a liquid. Can you only give me an example? Remember, once again, liquid should be a continuous medium. Alva. Gas should be suspended in it. Let us first of all go with it. And let me give you a name of it. It is called as what? Foam. Alva. So whenever you're using certain detergents in your house, when liquid it is a continuous medium. On top of it, we are seeing what? The lather, the soap particles, the nore anta heltivalla, that is called as a gas particle suspended. So it can be a type of a colloid called as foam. So what is, can give an example? Froth, alva, the froth, and also the whipped cream. Whipped cream will be an example for your gas in liquid. The type of a colloid is called as what? Foam. Okay. The next class, let us say, of course, alva, here just you are having two: dispersion medium. Take over here as a dispersion medium. Here is your dispersed phase. Dispersed phase. Here is your type of colloid. Type of colloid, and here is your example. So of course the dispersion medium ಅಲ್ಲಿ solid node ಆಯ್ತು, liquid node ಆಯ್ತು. Next ಯಾವ್ದು ಉಳಿದಿದೆ? Yeah, it is your gas and a gas. Only two categories we are going to see over here. That is what? Solid in gas. First we are going to see, remember, it is called as what? Aerosol. What it is called as? Aerosol. Very much important. So solid will be suspended in your gas medium. Can you only give me an example? Of course, anybody who is going very fast in your vehicles, certain times whenever the wind which is striking your face will be also struck with the small stones. Alva, have you ever observed it? Yes. So these are an examples for your solid phase will be existing in your gaseous medium. Alva, air alli dust particles irutte. So what type of a colloid it is? Aerosol. Can you give me an example? Of course, I mentioned it could be your smoke. Smoke ಆಗಿರಬಹುದು ಅಲ್ವಾ, ಸ್ಮೋಕು ಅಥವಾ ಡಸ್ಟ್ ಅಲ್ವಾ, ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗಿರುತ್ತೆ, ಏರ್ ಅಲ್ಲಿ ಫೈನ್ ಸ್ಮಾಲ್ ಸಾಲಿಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ವಿಲ್ ಬಿ ಎಕ್ಸಿಸ್ಟಿಂಗ್. ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಡಸ್ಟ್ ಅಥವಾ ಸ್ಮೋಕ್ ಅಂತಾನು ಎಕ್ಸಾಂಪಲ್ಸ್ ಕೊಡಬಹುದು. Of course, the another is that of your liquid, what I have explained when I was starting this chapter. So this is also called as what? Aerosol. So in other words, sometimes it is also called as a solid aerosol. It is called as a liquid aerosol. But generally we call as what? Aerosol. Remember, they can ask you, what do you mean by aerosol anta keldaga? Of course, you should be mentioning that the dispersion medium is a gas, whereas a dispersed phase can be a solid or a liquid. In case if they ask, what do you mean by solid aerosol? Then you should be specific with respect to that of your dispersed phase. Coming with respect to the liquid aerosol, of course, as I mentioned, it could be your fog. Remember, I'm writing as a fog, not as a smog. It is fog. Then it would be your mist. Mist agirbodu. And most important, your insecticide spray agirbodu. Insecticide spray. Alva. Allu kuda enagutte jet of gas barutte first. As soon as they spray, first gas barutte. A gas jute en barutte, your liquid droplets will be there. Gas will be the continuous medium, and in that continuous medium, fine particles will be suspended, which will be a dispersed phase, that is your liquid. So that gives your fog, mist, or insecticide spray. Is that clear? So let us have a close look now once again. Of course, we have described or we have classified the colloids on depending upon the physical state of your dispersed phase and a dispersion medium. What did we see? So when the dispersed phase is a solid and a dispersion medium is also a solid, the type of the colloid name is called as what? Solid sol. Examples we have seen the colored glass or the gemstones. Then we saw the liquid is your dispersed phase which has been dispersed in a continuous medium of dispersion medium, that is your solid, which is called as what? Gel. And examples is your cheese, butter, jellies, all those things. Similarly, dispersed phase is a gas, dispersion medium is a solid. The type of a colloid is called as what? Solid sol. Example is that of your pumice stone, foam rubber. Coming to the another phase now, solid which has been dispersed in a liquid, which is called as what? Sol. Examples is your paints, cell fluids. Of course, now when you come very much important, liquid dispersed in a liquid, it is called as what? Emulsions. Example is that of your hair cream and milk. Don't get confused with butter and milk. Coming with the gas suspended in liquid, the type of a colloid name is called as foam. Examples are froth and whipped cream. Coming with respect to the dispersed phase and dispersion medium with respect to solid suspended in a gas, which is called as a solid aerosol or just aerosol. Examples is your smoke or a dust. Alva. Coming with respect to liquid and suspended in gas, it is also called as what? Liquid aerosol or just aerosol, which is your fog or mist or insecticide spray. So how to remember it? Of course, remembrance is very much important. When you are just looking certain things in your home, for example, if you are looking for paint, it should come to your mind, yeah, it is an example for solid suspended in liquid, which is what? A sol. As soon as you see a milk, you should come to your mind that, yeah, it is what? Liquid is suspended in a liquid, which is an example of your emulsion. Of course, foam, whenever you are using your bucket of water, which has been put with some rin or surf, you should come to your mind, yeah, it's a foam. Alva froth barta untu. Hagar artha enu? Kelabhagadalli full neeru untu. It's a continuous medium of water, which means what? Liquid. And on top of that, we are seeing the froth. What is that? Dispersed phase is a gas. Yes, it is an example for your foam. That should come to your mind. So when you're seeing the day-to-day life examples, you should relate it with that of your chemistry part. Is that clear? So these are the certain important things. Very much important to remember its names along with its examples and what will be the dispersed phase and a dispersion medium. Remember how to write it. First you write the dispersion medium as a constant. Then go on changing with solid, liquid and gas. Once you try this one, easily you will be remembering all these names. So whenever you're writing its name, try to relate your examples at how it is relating. How the dispersion medium is a solid, how the dispersed phase is a solid. As an example, I have said, pumice stone, it is like this. Like a stone and you can just see certain small pores in it. So this is what a solid part. So E pores your gas particles will be embedded. So solid is what? Dispersion medium. And in that pores what has happened? Your gas has been suspended. So it is a greater example is called as what? Solid zone. So you have to relate your examples with that of your dispersed phase and that of your dispersion medium. And when quite interesting, whenever your dispersion medium is a gas, of course the colloid name is called as what? Aerosol. Here also you have to relate when solid is embedded in gas or solid has been dispersed in gas, that means what? It is dust particles. You are experiencing it whenever we are going in vehicles. Of course wind or the air which is coming and striking our face, of course we can feel certain times stones are hitting us. What is happening over there? The continuous medium is your air, whereas the solid particles which is striking your face will be your dispersed phase. So that is an example of what? Solid aerosol. The fog or the mist, as I said, and when you're going for a morning walk, you can just feel the water droplets on your face or your body. What is happening? The continuous medium is the air, whereas the suspended particles are the liquid droplets. So which will be called as what? Liquid aerosol. Is that clear? So now let us go with the next classification, which will be based upon the interaction of your dispersed phase and your dispersion medium. So now second classification is what? Classification which has been based on the interaction. Alva, interaction between dispersed phase and the dispersed medium. Dispersed phase and the dispersion medium. So what type of an interaction is existing? We will be seeing. So basically you have to remember it has been classified into two types. One is called as what? Lyophilic, and another is called as what? Lyophobic. Let us first understand its word to word meaning. Lyo means what? Liquid. Philic, can you please explain? Yeah, let me give you an example if you're not remembering. So when we are saying as an electrophiles, alva, electrophiles. Philes means what? Loving. Electro means electron loving. Alva, electrophiles means electron loving. Similarly, when you say as a nucleophiles, what does it mean? Nucleo means nucleus. Philes means loving. So nucleus loving. So when I am saying as a lyophilic, that means what? It is liquid loving. Liquid loving. Similarly, when we come with lyophobic, alva, lyo means as we have come to know that it is liquid. Phobic means what? For example, certain cases, certain will be having certain disorder like acrophobia. What do you mean by that acrophobia? That means a person hates the heightness. Jasti height hoda kelgi nodidare they will be feeling much frightened. So they are hating the height part. So hating is called as what? Phobia. So illa we use phobic, that is what? Liquid hating. So lyophilic means what? Whatever the substances, the dispersed phase is there, that is liquid loving. Whereas in lyophobic, what is happening? The dispersed phase is liquid hating. In simple words, let me take my liquid over here as what? The dispersion medium, because it is a continuous medium. So what happens in the first case? The dispersed phase is loving the dispersion medium. Alva. So in chemistry, of course, we can't use the word as loving. So what we can say, the first point to remember in lyophobic, that is dispersed phase. Dispersed phase has greater affinity. Alva, has greater affinity. So instead of using the word as loving, I am using my chemistry term affinity. Has a greater affinity towards dispersion medium. Towards dispersion medium. This is the first important thing. Alva, word to word hoda hai na, liquid loving. Which is liquid loving? If for example, electrophiles anta ಹೇಳ್ತೀನಿ. Electrophiles anta electron loving. Which one is loving electron? Of course, the incoming group alva. So that will be what? Negatively charged. So negatively charged that will be of loving your positively charged. Electrophiles means what? They are having a positive charge species. Yes or no? Here also liquid loving means what? Whatever the dispersed phase is there, that is loving your liquid. That is, in simple words, your dispersion medium. So dispersed phase has a greater affinity towards your dispersion medium. The first point of your lyophobic will be what? Of course, whatever the dispersed phase is there, that is hating your dispersion medium. So what we can say, the dispersed phase has no affinity towards dispersion medium. Yes, of course, Alva, we can say in these terms. So here the interaction between the dispersed phase and dispersion medium is favorable. They are interacting with each other, we can see. So interaction is present between that of your dispersed phase and a dispersion medium. In which one? Lyophilic, liquid loving. In lyophobic, what is happening? There is a much hatredness. That means there is no interaction. It is not favoring any interaction, or there is an unfavorable interaction between your dispersed phase and that of your dispersion medium. Alva? Illi dispersion phase ಮತ್ತು dispersion medium ಮಧ್ಯದಲ್ಲಿ ಒಂದು interaction is present. They are trying to bond with each other. Whereas ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಉಂಟು, dispersed phase ಮತ್ತು dispersion medium ಅಲ್ಲಿ they are not favoring ಆ ಒಂದು ಬಾಂಡ್ ಫಾರ್ಮ್ ಮಾಡಕ್ಕೆ ಇಷ್ಟಪಡ್ತಾ ಇಲ್ಲ. They are repelling each other ಅಂತ ಹೇಳ್ಬೋದು ನಾವು. So this is the first important point. Coming towards their stability, do remember your lyophilic colloids are always more stable. Very much important. They are very much stable. Of course, what happens? Why? Because they are having a much good interaction. Whereas here what happens? They are the less stable. They are less stable. Easily they are parting off. Alva begane separate ಆಗ್ತಾ ಉಂಟು. So they are what? Less stable. Coming to the third point, let us say. Remember, your lyophilic process is a reversible process. What is that? Your lyophilic colloids are what? A reversible process. So whatever the interaction is there, that can be also be aparted with each other. But do remember, your lyophobic is an irreversible process. Is an irreversible process. Okay. This is the most important point. Of course, we are going to deal with it in the properties of colloids, but just for a while, you just remember that this lyophilic colloids do not exhibit, what it is, do not exhibit Tyndall effect. Tyndall effect. Very much important. This Tyndall effect is an optical property. I am mentioning once again. It is an optical property. That is your light phenomenon. Okay. An optical property which will be exhibited by your colloids. But remember, your lyophilic colloids do not exhibit your Tyndall effect. We are going to understand this Tyndall effect in a very good manner in our later videos. Okay. Coming with respect to the fourth point over here, lyophobic. Of course, what happens? Your lyophobic exhibit your Tyndall effect. Exhibit your Tyndall effect. Very much important, the distinguishing. How can you distinguish between your lyophilic and lyophobic? So in lyophilic, the dispersion phase is having a greater affinity towards your dispersion medium. Dispersed phase is liquid loving. Lyophobical ಏನಾಗ್ತಾ ಉಂಟು, there is having no affinity. That is, dispersed phase is having no affinity towards your dispersion medium. The dispersed phase is liquid hating. Coming towards the stability, the lyophilic colloids are more stable, whereas that of your lyophobic are less stable. Your lyophilic are reversible, your lyophobic are irreversible. And do remember, your lyophilic colloids do not exhibit the Tyndall effect, an optical property of your colloids, whereas that of your lyophobic colloids exhibit your Tyndall effect. Then what are the examples of this lyophilic? Of course, it could be your starch. So starch is an example of your lyophilic colloids. Do remember. It could be your rubber. which has been mixed with a suitable liquid, even that of your gum. These are all examples of what? Lyophilic colloid. But can you give an example for your lyophobic, which is actually very much important? Your lyophobic colloids are very much important. So basically it is your sulfur sol. Sulfur sol. Even that of your silver sol. Do remember, I am using the words as what? Sol over here. That means what? Dispersion medium is a liquid, whereas the dispersed phase is what? Solid. Alva, that is the reason. Sulfur sol. Silver sol. Remember, your gold sol also. Gold sol. Even that of your aluminium hydroxide, AlOH thrice sol. See, in each and every case I am using the word as what? Sol. Medium, the dispersion medium is a liquid, whereas the dispersed phase is your solid. Coming to the most familiar example, your mud water. Your mud water is also an example of what? Lyophobic alva. What is happening? ನೀರು ಮತ್ತೆ ಅಲ್ಲಿನ ಮಣ್ಣಿನ ಪಾರ್ಟಿಕಲ್ಸ್ ಒಂದು ಜೊತೆ ಒಂದು ಇಂಟರಾಕ್ಟ್ ಆಗಕ್ಕೆ ಇಷ್ಟಪಡೋದಿಲ್ಲ. It's an hating part. So your mud water is also an example for your lyophobic. Similarly, you can also say as that of your As2S thrice. Arsenic sulfide. As2S thrice sol. Once again I am using the word as sol. Your sulfur sol, your silver sol, your gold sol, aluminium hydroxide sol. So they are all, what is happening? It's all lyophobic. That means what is happening? They are having no mutual interaction. There is no interaction between your dispersed phase and the dispersion medium. So this was another important classification. So here when I am choosing the medium as any liquid, I am using the word as what? Lyophilic or a lyophobic. If I am very much particular about the liquid and I am taking it as a water, if my dispersion medium is a water, remember, if my dispersion medium is the water, so what can you give the name? Water ಗೆ ಏನಂತ ಹೆಸರು ಕೊಡಬಹುದು? Hydro ಅಂತ ಕೊಡಬಹುದು ಅಲ್ವಾ? So that is the reason. If the suspension, whatever this dispersed phase is there, if it is loving your water, then what you can call those substances as your hydrophilic. If it is water hating, then it will be called as what? Hydrophobic. So when I can use the word as hydro, whenever your dispersion medium is your water. But since here I have taken as a general, as a dispersion medium as a liquid, so what I am choosing here as lyophilic if it is liquid loving, lyophobic if it is liquid hating. So in our next video we are going to see another important classification which is based on the type of particles in your dispersed phase. Very much important topic. Type of particles in dispersed phase. So through this classification we will be able to understand, through this important third type of classification we will be able to understand that how does the soap, whenever you're using your soap to wash your clothes, how does that soap is having the capacity to remove the dirt from your clothes. So that part will be concentrated by utilizing the classification of your type of particles in your dispersed phase, which will be seen in our next video. Okay.